You are welcome to JoeNewton Online Physics and Maths. In this class, we have physics question on the board to solve. However, before we start, compliment of the season to all of you. Happy New Year. Okay, the question is taken from frictional force, and of course, force and motion go together. Okay, we have a box on a platform. We have a box on a platform, a frictional effect platform, so that this is an acting force, Fa, dragging this box forward. Then this is an opposing force, that's the frictional force, opposing the motion of this box being dragged on this platform, on this rough surface with frictional effect. So the question now, and the mass is of the box is given to be 2 kilograms. The question now asks us to find the acceleration given to that body, this box or this object, by the force. Then B says the coefficient of friction. Okay, in solving this, first of all, we have to find the net force, because the force that will give the body acceleration is the effective force, the unbalanced force, or the net force. Had it been that there is no frictional force effect in the motion of that body, then the acting force now takes it all. Okay, now we have this. So our net force, we call it F net. Our net force will now be equal to acting force or applied force minus the frictional force. So this is the applied force. The applied force. This is the frictional force. Friction. The frictional force opposing the motion of the body. Okay? Now, remember, we know that friction is the force that opposes the relative motion between two sliding bodies, that two surfaces sliding over each other. Okay, now this will now give us our applied force is 11 Newton minus the frictional force 5 Newton. So we now have that 11 minus 5 is 6 Newton. So the F net, or the effective force, or the unbalanced force in that system is what? 6 Newton. Okay, now going further, the A question asks us for acceleration. Therefore, we now have that acceleration A. Recall that F is equal to ma. From here, A will be equal to F over m. So force is equal to mass times acceleration. Of course, by force here we mean the what? The effective force. Therefore, acceleration will be equal to force divided by what? The net force divided by the mass. Since the mass is already in standard unit of kilogram, then we don't need to do any other conversion. Remember, if the mass is given in grams, you have to convert to kilogram. And do not forget that 1000 grams is equal to 1 kilogram. Therefore, in that condition, you divide by 1000 to get the value in kilogram. So we progress. Our A here will be equal to our force, our net force here. Remember, we are working with net force. Our net force here is 6 Newton divided by the mass of the body, 2 kilograms, which is equal to 3 meters per second square. Don't forget to put the unit of acceleration, meter per second square. Then B question. The B question asks us to find the coefficient of friction. Okay, now for the coefficient of friction, remember that we have that acceleration due to gravity is approximately given as constant to be 10 meters per second square. So, unless otherwise given, then under this condition, we remember that for this body on this platform, there's a force acting upward here. That's the pressing force, known as the normal reaction. There's a force acting downward here, which is the weight of the body, of course. So, and that weight of the body is equal to mass times acceleration due to gravity. That's the weight of the body. Okay, remembering this now, we will now be able to go further. Okay, good. So, we have that the weight of the body is equal to mass times acceleration due to gravity. And recall that normal reaction is equal to the weight of the body. The normal reaction is equal to the weight of the body, is equal and opposite to the weight of the body. So, this will now give us equals to mass times what? Acceleration due to gravity. Therefore, our normal reaction is equal to the mass of the body is 2 kg times 10 acceleration due to gravity. That will give us 20 Newton. Okay? So that's the normal reaction, which is also the weight of the body. Then, now, for the coefficient of friction, we now have that the coefficient of friction, we call it mu. So we have that mu is equal to frictional force over normal reaction, because frictional force is equal to mu times normal reaction. That is it. So remember this. So with this knowledge, we now have that our coefficient of friction is equal to the frictional force. The frictional force is 5 Newton. Do not forget that our F applied is 11 Newton. Our frictional force is 5 Newton. Do not forget. So we have that 5 Newton over normal reaction, which is 20, which is equal to 1 over 4, because 5 divided itself is 1, 5 divided 24. So when you go further to get this in decimal, that will give you 0.25. So that's the coefficient of limiting friction for this body. So the coefficient of friction of this body or this system is what? 0.25. Please remember that we have to deal with what? The frictional force in this solution. Thank you for paying attention to this class. I believe with this, you can tackle similar questions. These questions are very important as taken from past questions of IGCSE and that of SSCE, as well as JAMB questions. Keep following me on my Facebook page for more. And also do not forget to subscribe to my YouTube channel at JoeNewton Online Physics and Maths. And also kindly share, like, and drop your comment or question in the comment section. Bye-bye.